All right, we're going to be graphing cube roots, and we're going to be solving radicals, more solving radicals. We're going to be doing section 7.4. Let's get started. All right, before we can do cube roots, we're going to actually graph cubes. They're going to be so nice. You got introduced to finding the vertex of things when we did absolute values and parabolas. Graphing cubes.
Oh my god.
It's going to be super nice.
All you're doing is taking the parabola and you're flipping one side of it.
Kind of, yes. If you put that in your calculator, I'm going to just do a general sketch. I'm not going to make it accurate, but it's going to come up like this and down like that, okay? And the vertex is at 0, 0. Now, it doesn't have the same numbers as out 1, up 1, out 1, up 3, out 1, up 5, okay? But I'm going to tell you their numbers so you can just know them, okay? All right, so we're going to start off. 0, 0 is the number, okay? So this is the optional thing. If I have a 0 and I plug a 0, if I plug 0 in, cube root of 0 is, 0 cubed is 0. What if I put a 1 in?
1.
1 cubed is 1. So we're going to have 1, 1. This gets reflected down here.
Do we have to write this the right
You do not have to write this part here, but I'm doing that so you'll understand why.
I have a question.
Yes.
When I graphed it, it looked like it stays flat on the
It kind of
x-axis for a little while.
it kind of does this.
It
I'll
must
show
be
you.
very dull curve.
It goes. It's called an inflection point. You'll learn that in calculus.
It
later.
looks more flat than that other one we ran into. that
Oh
was
my
kind of
gosh,
less
so
flat.
all we're doing is we're putting the cubes, we're doing it just like we did, except all it does is turn like this.
Yes.
So then 2 times 2 is
Now
4.
the trouble comes up here. It's not going to be 4 though. When I plug a 2 in,
It's going to be 8.
it's going to be 8
Why is that?
because 2 cubed is 8.
Oh.
Okay. So I'm going to come up here at 2, 8.
And then we
2,
can't do
1,
anymore.
2, 3, 4, 5, 6. Yeah. Okay. Yep. But I want a different color. No. All right.
And then you do it on the
And I'm going to
bottom.
have -8. Okay, down here. It's going to be reflected down here. -2, -8. Part is, let me draw this.
Okay.
This is our cube. It's going to keep going up there and keep going down here. Okay, so instead of having to draw this table every time, I think the trick goes like this. You're going to go out 1, up 1, just like before. Here, out 1, up 1, and out 1, up 7.
So you don't go
1,
out.
2, 3, 4, 5, 6, 7.
Oh,
so
so
it's-
when you say 2, 8, you're starting at the very 0, 0.
Yes,
Going over
yes,
to, okay.
yes.
That's where I was
So my
confused.
trick are the numbers that you remember we did this parabola. It was 1 and 3 and 5. Well, it's going to be 1, 7. You don't have to worry about the rest of them. It's 1, 7, and then down 1 and down 7. All right? 1, 7 is your trick for cubes. Are you with me so far?
Yeah.
Okay. We're not going to do anything super complicated with our cubes. We're not going to put plus something squared or anything like that. So if you have this basic shape, what are we going to do? What's the -4 going to do to that graph?
Move it to the -4.
Move it down, right? So it's going to start at the -4. You're not going to be able to get all your 1, 7s all the time because of the graph. But we're going to go out 1, up 1, out 1, down 1, and then 7, out 1, up 1, 2, 3, 4, 5, 6, 7. And you're not going to be able to get the one down here, okay? It's just not going to fit. But you know what the general graph shape looks like. It's going to come here. I'm going to go like... All right, now we have to do the domain and range.
Don't, makes me think of, Doritos, Doritos.
Number
Really had to read.
one,
So your fault.
domain
Gosh.
and range. If I start in this X place, where am I going to start hitting this? Am I hitting it somewhere?
Yeah.
I am hitting
You're already
it. Somewhere
hitting it.
down here,
It's
I
already
am hitting it. This is going to keep going out, now. So where will I hit it?
You're
Everywhere. How do I say everywhere in math terms? Not infinity.
Everywhere.
Not infinity. It's called all real numbers. Before you write all those 3 words, you can write the words. Just a second. There's a symbol for it.
Isn't there like
All real numbers Just a second, I'm going to show you something.
That's
I'm trying to
not
remember
a
what he did on
symbol.
Khan Academy. I forgot what it was.
There is a symbol for it.
Is it a,
It's
is it a
it's an
delta?
R. It's a
It's
fancy
not-
looking R. It has like two little things,
Oh, yeah, it's the R.
and then it's like that. It's like this fancy R. I like to make it bigger. It's an R. A big old fancy R
I
means
want
all real
one.
numbers. Okay.
That is so dope.
What about the range? When will I not, or when will I touch this thing on the Y values? Everywhere. And so how do I say everywhere? All reals. And you can do that little fancy R. The
Well, is this
the
what it
answer
looks
key
like?
will not have that fancy R, but I will accept that fancy
That
R
fancy
as
R
your
is-
answer. All right. So what about number 2? What's the domain and range?
Wait, why is the range?
If you wrote the little R, you don't write all real numbers.
No, why is the range the?
Well, both ways it touches everything.
Because if I go like this, I'm
Yeah.
touching it no matter what.
Yeah.
Okay? All right.
So you just
It's
say
actually
all
easier to
numbers.
see on the range than it is on the domain.
Well, why would you do it on the domain? Because domain you don't even touch it until
You do, because this thing is going to go
Oh,
out
it
and
goes
out and out and
on
out.
and
So when
on
I'm
and
actually
on.
hitting it way down here, you just can't see. Okay?
So do we do that every single problem?
For all of them?
All right, so we concluded that the domain and the range for graphing cubes is always going to be all real numbers. Okay.
That is a cool looking R.
Number 5. We're going to now do cube roots. Cube roots.
Oh, okay.
And domain and range, okay? If you remember, when we were doing square roots, the square roots had smiles, and then the roots went on their sides, okay? When we did cubes, we went like this, and then now these are going to go on their sides. Now, both of them are going to go on their sides, so I'm going to draw a general gist. We're going to go like this and that.
Why?
Why what? The cubes went like this, and now these are going to just turn over on their sides.
Because it's a square root.
Because it's a cube root. This is a cube root. So, we remembered that the trick was out, one up, 7. That's exactly how this is just going to go on its side. Okay? So let's do that with this cube root here. I did a general gist of it. So we're going to be at 0, 0. Out 1, up 1 on both sides. It looks almost the same, but instead of going up, we're going to go to the side. We're going to go 7 now. 1, 2, 3, 4, 5, 6, 7. And back. Down 1 back. Domain and range of these? Number 5?
It has to be all real numbers too, huh?
All real numbers.
So the only thing we have to do on these is graph it and then fancy R.
Yep, graph it and fancy R. I see. Okay. There we go. All right, number
I did a combination.
6. What does the +3 do to the graph?
Move it over. Up 3.
Up or over? Which is it?
Up.
Up. Yes. Up 3.
Everybody's graph goes up.
All right.
Thank you for being
And
the
then
one
we're
person
gonna
that laughed.
up 1 over 1 on both sides, and then up 1 over 7.
What is it I just said?
1, 2, 3, 4, 5, 6, 7. And back. 1, 2, 3, 4, 5, 6, 7.
Same. Did I do it wrong? No, I didn't. I think that's right.
Domain and range. Let's do number 7. What does that +4 under the cube root do?
Move it over -4.
Which direction? Towards the positives or towards the negatives?
Towards the negatives.
We got right or left?
Left.
Left. Towards the left 4. So we're going to start back here, right? We're going to do going back 1 and forward 1 on the diagonal there, right? Then we're going to go with our 7s. We can't go 7 backwards, but we can go 7 forward. 1, 2, 3, 4, 5, 6, 7. We're just going to have to draw the general curve. Domain and range for number 7.
I mean, it could be the curve of a Dorito.
Or Pringle.
I'm not gonna ask.
How about domain and range?
Ooh, now I want some Pringles.
What have you done? You should not have brought it up.
Ooh.
Domain and range. All reals.
Oh,
All
wow,
right.
and then you turn the page, and it's like...
So, all that parabolas moving up and down, finding the vertex pays off right now. Your jobs are so much easier because of it. All right. We're going to be solving some radical equations. Don't write this down just yet. We're going to analyze this equation, okay?
Square root of b equals 8.
How do I solve this equation? What do I do to it? What do I do to solve it? What do I do to both sides?
Square it. B equals.
Do I square root it or do I square it?
B equals 64.
Square it, right? So we square both sides, right? And I'd have b equals 64, correct? Okay, so my question to you is, this b, what exponent does the b really have on it?
To the worst.
What does this one right here have on it? What's the exponent for that?
0. -2. I have no idea.
Plus or minus.
Isn't it 0 because then it equals 1?
Oh, it's b to the 1/2.
The 1/2. Are you
Now
with
I
me so
follow.
far?
It was really huge. Oh, it's b to the 1/2.
I wasn't sure.
Right?
if you
sorry,
like
I
the
said it was
b.
Are you with me so hard? This is b, this square root b is the same as b to the 1/2, correct?
Yeah.
And you just a moment ago told me to square both sides. What is the relationship between the 1/2 and the 2?
They cancel.
Yeah.
They do cancel.
They become a...
What else? There's a vocabulary word that describes these two things. They are the reciprocals of each other.
Good job, Heidi.
High five. We got some high fives going on. All right. Remember that if they're reciprocals, if you multiply reciprocals together, like 2/3 and 3/2, what do you get?
Mere 1.
1, okay? And getting a 1, in essence, is like canceling them out,
So
okay?
you only have b equals 8.
So you only have b to the 1 power, and that would just keep it as a b, right? So if we could find the reciprocal of the exponent, then we would be able to get rid of that exponent, okay? All right.
So b equals 1?
So the questions I just asked you were, what exponents did we use? And this one was a 1/2, and we used a square to cancel it out, and the connection between the first and the second exponent was that they were reciprocals, correct?
Okay.
All right. So
You're gonna have to show me this.
if I am going to do number 11, and if I want to solve this for A, I want to do the reciprocal of 3/2 to get rid of it, correct? So if I do the reciprocal of 3/2 on this, 2/3, excuse me, then I must take 243 to the 2/3.
300, yes, 300.
And how do you do that? We're getting our calculators out. That is exactly right. Do it. We have calculators. Put parentheses around your 2/3 when you do that on your calculators. What is 243 to the 2/3? 243
Wait.
to the
49.
49.
Okay. All right, number 13, we have to isolate that variable. We got to get the negative out of there. So what are we going to do to get that negative out of there?
Multiply them both by a -1.
Yes, or divide either way. So we're going to get 4 equals 4 to the 1/2. Should be n to the 1/2.
Let's say.
What am I going to do to get rid of the half as the
Wait,
exponent?
we multiply the first thing by
Where about
-1?
You get
Square
2.
both sides.
Do we multiply the first thing by -1?
Yes.
You get
Yes.
2.
You don't get 2 because we're going to square, not square
16.
root.
Why do we square?
Because
half.
the reciprocal of a half is 2. All right, so we got n equals 16 on this one because 4 squared is 16. We have some things to do before we can do anything with this fractional exponent.
hate that
We got to
sentence.
move the 3, the -3 and the -4. Which do I move first?
The -4, right? You distribute, don't you? Oh, you mean move to the other side?
We have to move them to the other
Let's
side.
get rid of that 3.
The 3. We're going to put some things together. Yes. So we are going to move these to the other side. And which one are we going to move first? Natalie says we're going to move the -3.
Can't we put the -3 and the -4 together and then move them?
That's a good
Because
question.
we would need to divide by the -4 and add 3 over. So we'd have to divide by, wouldn't we?
The order of operations says that we multiply before we add and subtract, and we don't know what x is to be able to multiply right here, so we cannot multiply. So we're going to have to move this. So this is like, let me do this. If you had 7 equals -4 plus 2x, what do you move first?
The -4.
The -4, because this is multiplying here.
Yeah.
And we can't do that first. So we got to move that over and then divide by 2. This is the same thing. This x plus 25 is like the x. I have to move the 3 over and then the 4.
That makes sense.
Okay?
So all we're going to do is add 7 to the other side.
No, you can't put together the -3 and the -4.
I'll
We're gonna
watch. I'm sorry.
We're going to add the 3 over here. What is negative 2,919 plus 3?
Negative 2,916.
Yes.
Yes. Negative 2,916 equals negative 4. X plus 25 to the 3 over 2. What do you want to do next?
We want to square. I mean,
Can we divide both sides by negative 4?
We're going to get rid of that negative 4.
Yeah,
Okay.
Don't we have to distribute it?
We can't distribute it because there's an exponent.
Oh, sure.
So we're going to divide by negative 4.
729.
729 equals x plus 25 to the 3 over 2. Now what do we do?
Now we multiply the 2/3.
Yes, we actually take the exponent, we take it to the exponent of the 2/3. So we do the reciprocal of the 2/3, and should be the 3 halves to make it 2/3. We raise
81.
this to the 2/3. And I heard 81. Please confirm that. I heard 81. Okay, 81. I have 81 equals x plus 25.
Subtract its 25.
Subtract the 25 and x equals, I heard 56. We're going to do number 17. What do you want to do for 17? What are we moving first?
Negative 8.
We're going to add the 8 to the other side, correct?
Oh, we added it right.
248 plus 8 is 256.
And then divide both sides by 4.
Divide both sides by 4. I'm going to move this over here so I have more room. And we'll make it a little bigger. There we go.
64.
Divide by 4. I heard 64.
Then do we divide? Not divide. So the both sides half.
To the both sides reciprocal.
2/3.
To
Half,
3/3.
right?
2/3. Because it's 3 over 2. To the. That's correct. With that to the button you have on your calculator.
16.
I heard 16. 2 people confirmed it, so I think we're there. And I'm going to move back to the green because I don't want to bother any person in this room.
I like it when it's kind of funny rainbow looking. So
So no matter which way she's going to bother someone, it's better
B
for her to
equals
bother her own
25.
daughter than anyone else.
B equals
So,
25.
yes.
I'm going to
that's what I got.
subtract 41. I'll have a negative b equals a negative.
B equals 25.
You said 25 or 30?
B equals 25, so that's the answer. I added the b over the other side and then subtracted the 16 just because I hate having a negative x value.
I agree too.
or a
I
negative variable.
usually do that too, but you know.
Is that it?
Yeah. I think. Let's see if there's any more.
What?
All right, let's review what we did today. We learned how to graph cubes and cube roots. And then we learned how to solve equations with fractional exponents by just raising it to the reciprocal power. All right?